Jai Hind, welcome to the course. So, we are discussing the network analysis theorem. In the previous video lectures, we carried out some problems on Thevenin's and Norton's theorem. Today, I am going to discuss problems on maximum power transfer theorem. How to carry out or how to solve a problem given using the maximum power transfer theorem. So, we know that maximum power transfer theorem states as the maximum power transferred by a AC circuit to the load if the load impedance is equal to the complex conjugate of the source impedance. So, this is the problem. In this problem, you are required to find the ZL and maximum power. So, just you have to find first value of ZL, and basically the given circuit is a AC circuit. So, in the AC circuit, ZL is equal to the complex conjugate of ZTH. That is, if ZTH is say RS plus JXS, then to have maximum power, ZL is RS minus JXS, which is equal to RL plus JXL. Okay. So, if this is the ZTH, so ZL will be like this. Here it will be minus JXL. Okay. So, RL is equal to RS and XS is equal to XL. Okay. So, in this way we can find out the ZL, and the second part is maximum power. Maximum power P max is VTH square upon 4 RL. Okay. So, you have to find this value of ZL and value of maximum power. So, what are the steps? So, steps first, remove ZL from the circuit and find equivalent impedance across AB terminals, which is called ZTH. So, remove this ZL from the circuit, replace all the energy sources by their internal impedance and find the equivalent impedance across the AB, what we did in the case of the Thevenin's and Norton. Second is find Thevenin voltage, VTH across AB terminals. Second step is, and the third is P max is equal to VTH square upon 4 RL. So basically there are 3 steps to carry out problems based upon the maximum power transfer theorem. So we will do this problem. So what we do? We just remove this ZL from the circuit, replace these voltage sources by their internal impedance, find the equivalent impedance across the AB terminals, that will be the ZTH, and to have the maximum power, ZL is complex conjugate of ZTH. So this is the approach. So determine first the determination of ZTH, means equivalent impedance across. It means equivalent impedance across AB terminals. So this is the circuit diagram. We have removed the ZL and replaced voltage sources by their internal impedance. The voltage sources are ideal in nature, so they have 0 resistance as internal resistance, and 0 resistance is replaced by the 0 resistance wire, so it looks like a short circuit. Now we have to find the voltage the impedance across AB. So this 5 ohm plus j 5 ohm is in parallel with 3 plus minus j 4. So we can easily find out equivalent impedance, this one. So this and this, they are in parallel. Okay. So this is the ZTS. So just to convert this rectangular into polar, then divide, multiply, and we get the ZTS. So this is the ZTS. So ZTH is this 4. Now, so ZL will be ZTH conjugate. It means 4 plus 3, 8, 5. So first you have to convert into the rectangular form. This is in polar form, so you convert into rectangular form. So this is ZL is 4.23 plus J 1.154 ohm. So this is the ZL. So ZTH is 4.23 minus J 1.154 ohm. So ZL is complex conjugate of ZTH. So this is your ZL. This is your ZL. So RL is 4.23 ohm, and XL is JXL. So XL is 1. J 1. R JXL. So this is the 1.1. J 1.154 ohm. So this is the ZL. So first part is completed. So now go for the VAB and voltage across AB terminals, that is the open circuit voltage. So open circuit voltage is nothing but it is the Thevenin voltage. So you have to find the Thevenin voltage. So this is the network, this is the, so you have to find the voltage across this AB. So what we have to do? We have to find the current through this circuit, and then either this is your VTH, plus minus. So VTH, either we go in this way, or in this way we can get the VTH. So, VTH is, so first you have to find the I, because VTH is drop across this ohm or drop across this impedances. So, this way we have calculate. So, 50 minus 25, this is the net voltage divided by total impedance, 5 plus 3 8, J5 minus J4, so plus J1. Now, converted into the polar form and divide it, we get this. So, this is the current, this is the current, this is your I. Now, write a line equation. So, starting with VAB, so VA, and we are moving, we are just we have written the equation for this loop. So, VA, we are moving against the direction of current. So, it is plus I into 5 plus J5 into this is your I minus, because we are going from the plus to minus terminal, voltage plus to minus. So, it is minus 50 angle 0 degree equal to VB. So, this is the line equation, or we can write another equation is VA minus 3 minus J4 into 6.94 angle minus 33.7, then minus 25 angle 90 degree equal to VB. So, we can get the VA minus VB. So, VA minus VB, which is nothing but VTH. So, this way either we can go for this equation or this equation, both are same, either use this one or this one. So, I have written there this one. So, VAB, so VAB is VTH. So, it is VTH is 9.80. So, VAB equal to this, and this is your VTH. Now, maximum power, so VTH square upon 4 RL. RL we have taken from the ZL, ZL is equal to RL plus JXL, and this is the wattage. So, this is the maximum power, this is the maximum power supplied by the energy sources to the load ZL, and to have the maximum power, ZL is complex conjugate of ZTS. So, this way we can solve the problems. We take the another problem. So, in this in the network given below, load consists of a capacitive reactance of 15 ohm and variable resistance RL. Determine the value of RL for maximum power transfer and what is the value of this power. And the circuit is like this, circuit is like this, it is this is your RL is variable, this is minus J 15 ohm, this is 10 ohm, J 10 ohm, and this energy source is 100 angle 0 degree, 100 angle 0 degree volt. So, you have to find the RL. So, in this case RL is mod Z, and Z is equal to 10 plus J10 minus J15. So, it is 10 minus J5. So, mod Z is 10 square plus 5 square. So it is 125 root over. So RL is root 125 is coming your 125. So 11 greater than the 11, so it is 11.18 ohm. Remember, this is the load is purely resistive, okay, because it is variable, and this is the constant. So in this case you have to take the mod Z. RL is not equal to 10 ohm, okay, remember. So most of the time students commit mistake here. In place of taking the, if the load is purely resistive which is variable, in place of taking the mod Z or mod ZS, we just take the RL is equal to RS. So most of the time students commit mistake here. Please take care. So RL is this. Now you have to find the VTH. So VTH. So for VTH, just draw the circuit once again. This is your VTH, and this is your 10 ohm, or other one is J10 ohm minus J15 ohm. This is plus minus 100 angle 0 degree volt. So from this circuit we have removed the RL from the circuit, and we have to find the VTH or VAB. This is your VAB, okay. So VTH is now the circuit is opened. So the current through this 10 ohm or my J10 ohm is 0 because the circuit is opened. So VTH is nothing but it is coming, VTH is equal to 100 angle 0 degree. Why? Because circuit is opened, current through the network is 0. So no drop. So same voltage is appearing across AB. So what is P max? So P max is VTH square upon 4 RL, okay. So VTH is 100, so 100 square upon 4 into 11.18. So it is coming 223.61 watt. So this is the way we can carry out the problems on the maximum power transfer theorems. So summary, what is summary? If load is complex in nature, okay, so ZL is complex conjugate of ZTH first, okay, and P max is VTH square upon 4 RL. Now second case is when load is purely resistive. In this case RL is mod Z, which is Zs square plus, sorry, Zs, this is Zs, we can write not Zs, it is Rs square plus Xs square, okay, mod Z, and P max is, so in this case P max is same Vx square upon Vth square upon 4 RL. So this is very important, because most of the time students commit mistake here. In place of taking the mod Z, we take the just RL is equal to Rs and carry out the examples. So this way we can carry out the problems based upon the maximum power transfer theorem. So this is all about maximum power transfer theorem. Carry out some more problems just to clear your idea how to solve the maximum power. So I am stopping here. So thank you very much. Jai Hind.